All right, so we're going to start talking about functions now, and to be able to do much, we need some definitions. We're going to start with some definitions. I'm not going to write them all down here. We're going to look at them in the textbook, okay, which is again linked above or below the video, depending on where you're watching this. We'll look at the textbook, and you can either take the time and pause the video, copy them down into your notes, or if you'd like, you can just bookmark the page on the book. Again, definitions aren't super important for us in this class, but they're useful so that we know we're all talking about the same thing. All right, so let's open up the book. We're in 3.1, and let's talk about a couple definitions. So we're going to start by talking about relations, because in this book, we're going to talk about, is something a function? And if it's not a function, or even if it is, we're going to start with a relation. So a relation is just a set of ordered pairs. Now, before, when we had graphs, that was an infinite number of ordered pairs. When I graph something and I connect the dots, that's making an infinite number of points all along the line. So graphs are examples of relations, graphs of functions, like we usually see parabola, that's a relation. A line, that's also the graph of a relation. Okay, but sometimes maybe it's not infinitely many points. Maybe it's only a finite number of points. So here is a relation. This relation has 5 points in it. Not infinitely many, only 5 points in this relation. And there's a domain and the range. So those are the next definitions. Domain and range are just sets of numbers. So it's the set of the inputs is the domain. So 1, 2, 3, 4, and 5. Those are all the inputs. That's our domain. The range is a set of all the outputs, which, as it comments down here, is 2, 4, 6, and 8. And we use the curly brackets, these braces. These braces show set. All right. So braces 1, 2, 3, 4, 5 means the set containing 1, 2, 3, 4, 5. It's like a little bag. The braces are like the bag, and we're putting the numbers in the bag. Okay, so that's a part of the definition, domain and range, input, output. In our input, the domains, the x values, are often called the independent variable. Just like when you remember when we were plugging in points to plot graphs, we'd plug in the x usually. That'd be the thing that we have control over, the independent thing. And then y would be an output. Y is the result. Y is the output, the dependent variable, because that y is dependent on what you plug in for x. Okay, so we'll kind of be using these terms a lot throughout this chapter, and we'll be utilizing and reinforcing these concepts some more. Just briefly introducing them right now. It's probably a good idea to pause and copy these videos down into your own notes. So the next thing that we're going to talk about is when is a relation a function. And so a relation is a function if each input, each x value, only goes to one location. So for example, this third one is not a function because there's an input that goes to 2 different places. Q goes to Y and Z. Since it goes to 2 places, it's not a function. And there's a reason why we talk about this. And the answer is kind of like, we want one answer. If I give you an X, the dependent variable, the result, the output should only be one thing. That's why we care about functions. And that's why Q should only go to one of these, not both. Because Q is going to both, it's not a function. If I give you an input, I want only one output. If I ask you a question, I only want one answer. And that's what kind of means function. All right, this definition down here. Okay, so that's a kind of rough introduction. We're going to use these with some examples to hopefully reinforce these concepts, and that'll be this video. All right. So let's get over to the notes. And let's get exampling. All right, we're going to start with example number 1, because it is the start of a section. And say, determine whether the following are functions. All right, so we're going to start with part A, and this is going to be a relation. We have this brace. This brace means a set, or it's also good for relations because the relations are sets of ordered pairs. The relation containing the numbers 1, 2, 3, 6, and the point 3, 8 as well. So there's 3 points in this relation, and something is a function if each input only has one output, if every question only has one answer. So let's look at the inputs. The inputs are 1, 3, and 3 again. That's the domain. The independent variable is x. So notice that 3 specifically, this is one input. 3 is going to 6, and 3 is also going to 8. So if I ask, hey, where does 3 go? You have 2 answers, 6 and 8. All right. So this is one input goes to multiple outputs. We're going to say, no, it's not a function. All right. And this can be visualized a little graphically as well. If we were to graph these points, 1, 2, might be somewhere around here, 3, 6, 3, 8. If we were to graph these, you'd see that 3 and 8 are directly, like they're on top of each other, right? They are vertically connected. I don't know. English is hard. But that's something that we're going to notice later with something that we're going to introduce is the vertical line test. Okay. And by later, I mean right now. Okay. Let's mention this real quick. So it's definition. The vertical line test. Sometimes it's going to be, whoa, what happened to that E? That poor little E. Sometimes we'll abbreviate this VLT. Says that if there's a vertical line that crosses the graph of a relation at least twice, more than once, then that relation is not a function. And we're going to use this vertical line test very frequently because it's a much simpler way, I think, of looking at whether something is a function or not. We just look and say, is there any line I can draw? Any vertical line I can draw? So in this earlier example, right, there's this vertical line that crosses the graph twice. Not a function. Well, let's use this with part B and the parts after B. All right, so same example. Am I putting 2 parentheses? I am putting 2 parentheses. Same example, part B. Let's look at a bunch of graphs. What about this parabola? Is there any vertical line that we can draw that crosses this parabola multiple times? I'm just drawing a bunch of vertical lines, but no matter where I draw these vertical lines, right? All of these vertical lines are only crossing once. So it passes the vertical line test. It is a function. It is a function. Let's do another graph. This one's a sideways parabola. So we just graph a bunch of vertical lines. In this case, we only need to graph one vertical line. Because notice this vertical line, right? This crosses twice. So here there is a vertical line. Well, pretend it's vertical. There is a vertical line that crosses the graph more than once. It fails the vertical line test. We're going to say, no, it's not a function. So I'm going to draw some more graphs. Here we got a line. Here we have the reciprocal squared function. You're going to be seeing this one more. Here we have the square root function. This is also going to be another common one. And then we're going to end with two kind of weirder examples. First one has a closed circle right there, and then an open circle down there. Remember that closed circles means that point is included, and open circles mean that point is not included. And then we'll have, let's do one more up here. Maybe it looks like this. And then an open circle on the bottoms. This is a piecewise function. It's the angry piecewise function because it looks like an angry face. And I literally just made it up today. But there we go. So pause the video, look at these, and decide which of these pass the vertical line test. Which of these are functions? Pause the video, get your answers down, and then we'll go through it together and see whether you are right or not. So looking at this first one does pass the vertical line test. It is a function. Second one is a little weird, but it also passes the vertical line test. There is an asymptote right here. We'll talk about what that means later. Those curves get really close to the y-axis, but they never touch it. One over here, the square root function, also passes the vertical line test. Now these last two are a little tricky because it's hard with my handwritten graph. Because if you look over here, right? If you look, it kind of looks like this line crosses both. But remember that it's an open circle at the bottom. The open circle is not included. Okay. Because that open circle, that's supposed to be an arrow. Because that open circle is not included, it actually does pass the vertical line test. All right. So these last two are indeed functions as well. All right, so all of these actually, except for the second one, are functions. Last example of the video. Part C. X squared equals y minus 5. And the hint is that I do want you to use Desmos here. You do not have to graph this by hand. If you graph this by hand, it might be a little tricky. It's a little outside the scope of where we're at right now. What we're going to do is we're going to pull up Desmos and then see if this passes the vertical line test. So the function is y. No, it's not y equals anything. This function is x squared. So remember, shift 6 for that caret. Get to the exponent, press tab to get out. X squared equals y minus 5. So it's a parabola. It opens up. It is a function, right? You can zoom out, passes the vertical line test. If you needed to export it, remember you could export it down here with share graph. But yeah, this one's a function too. Another thing that was not asked was if we had y squared equals x minus 5. This would again be a sideways parabola and this would not be a function. But the one that was asked is a function. All right. And so that's our answer. The answer is yes, it's a parabola. There we go. That's domains, ranges, inputs, outputs. Independent variables are usually your x's. Dependent variables are usually your y's. I dropped my pen. Okay. And domain is all of the x's, range is all of the y's. I have already said that. And that's basically what we have here. Good luck on the homework problems.